Today I will discuss the topic of one-dimensional elastic collision. I complete derivative part of the one-dimensional elastic collision. Take the support of this video and practice your own by using paper and pen. And whenever doubts will come, then open this and follow those steps. Whatever you are finding the results of those final velocities in case of one-dimensional elastic collision. Okay. Now I'll start that one now. One-dimensional elastic collision. One-dimensional elastic collision. Okay. Now for that purpose, you consider two bodies. Here I am writing the points now. Two bodies of masses m1 and m2. Two bodies of masses m1 and m2 moving with initial velocities u1 and u2. Initial velocities of those two bodies. After collision, v1 and v2 are final velocities. After collision, v1 and v2 are final velocities. Here we are assuming one condition, m1 greater than m2 and u1 greater than u2. At this condition, we observe the one-dimensional elastic collision final velocities v1 and v2. Now here two points, the two principles it should be obeyed. One is called law of conservation of momentum. Second one, law of conservation of kinetic energy. Law of conservation of momentum and law of conservation of kinetic energy, both these laws obeyed by one-dimensional elastic collision. To verify those, first you consider the mass m1 whose velocity u1, another body of mass m2, velocity u2. This state is before collision. Before collision. Then what happened here? Both the bodies are interacted each other. Then it will exchange the force or the energy one among another. This is called during collision. During collision. And later on, these two are moving with the velocities m1 v1. Another one is m2 v2. This is called after collision. This state is after collision. Now we will start to verify the law of conservation of momentum. Other one is law of conservation of energy. That one I will write here. The first one we are verifying law of conservation of momentum. We should verify the first one is law of conservation of momentum. Now from this what you are defining? Momentum of system before collision should be equals to momentum of system after collision. Momentum of system before collision should be equals to momentum of system after collision. Then you write now m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. We observe now before collision these two, after collision these two. After collision, before collision sum of these two, after collision, because momentum equals to m into v, m1 u1 plus m2 u2, p1 plus p2 indirectly. Here also m1 v1 plus m2 v2. Move this term on left side, m1 u1 minus m1 v1 equals to m2 v2 minus m2 u2. Now take the common now, m1 of u1 minus v1 equals to m2 of u1 minus v2 minus u2. You give that one number for this value, that is 1. m1 of u1 minus v1, m2 of v2 minus u2. Now the first one is verified, that is law of conservation of momentum is verified, and you will move to the second one now, that is law of conservation of kinetic energy. That one you are verifying. I clean this part. I will take that derivation now from the diagram. Now that one here I will conclude some more steps here. That is second one is law of conservation of kinetic energy. Law of conservation of kinetic energy. Okay, now from this what you are saying now, kinetic energy of system before collision should be equals to kinetic energy of system after collision. After collision. Now I will take the point here now of m1 u1 square plus of m2 u2 square, that should be equals to of m1 v1 square plus of m2 v2 square. Of m2 v2. Move the terms on left side. I will do this here now. Then what will come? Of m1 u1 square, another one move on left side, minus of m2 v2 square, that should be equals to remaining of m2 v2 square minus of m2 u2 square, and move the terms of m1 u1 square minus of m1 v1 square, of m2 v2 square minus of m2 u2 square. Cancel the of completely both sides. Then what will come? m1 u1 square minus m1 v1 square equals to m2 v2 square minus m2 u2 square will come. Here you take the common now, m1 of u1 square minus v1 square equals to m2 of v2 square minus u2 square. Now you give to this number, after the earlier that series will come, it is 2. Now do the step here, it is 2 by 1. I repeat this step once again. m1 of u1 square minus v1 square equals to m2 of v2 square minus u2 square divided by this one now, m1 of u1 minus v1, and here second one divided by m2 of v2 minus u2. Now the m1 cancel, here m2 cancel. You expand this value now, u1 plus v1 into u1 minus v1 divided by u1 minus v1 equals to v2 plus u2 into v2 minus u2 divided by v2 minus u2. What form it is? A plus b into a minus b. Here also a plus b into a minus b, because it is a square minus b square form. Eliminate these two values and eliminate these two values. Then u1 plus v1 equals to v2 plus u2. And move the terms on one side. u1 plus v1 minus u2 equals to v2. It is one value. Similarly, v1 keep it here, move on other side now. Then v1 equals to v2 plus u2 minus u1. These two values help us to find the results now. One is v2 and other one is the v1. What is the value of the v2? u1 plus v1 minus u2, this one. And what about the v1? That is v2 plus u2 minus u1. Be careful u and v value, otherwise the results are not getting correctly. Okay, now where you are taking these two steps, substitute these two values one after another in this place now. In equation 1, we are substituting these two results. I will do that now. I repeat this step once again for the substitutions purpose. Okay. Now, m1 of u1 minus v1 equals to m2 of v2 minus u2. You take that step once again and substitute those values. I should write once again the same step. What is that value now? m1 of u1 minus v1 equals to m2 of v2 minus u2. This is the step. Now the first one is substitute v2. Substitute v2. Do that now. m1 of u1 minus v1 equals to m2 of, what is v2 from this now? u1 plus v1 minus u2 minus u2. Now m1 u1 multiply minus m1 v1 equals to m2 of, first term u1, second term v1 minus 2 u2. Now right side also should expand. m1 u1 minus m1 v1 equals to m2 u1 plus m2 v1 minus 2 m2 u2. Minus 2 m2 u2. Do that now. Now the v1 of, you keep on right side now. That means move this m1 v1 term on this side. Already have m2 v1. Now another term is coming, m1 v1. Remaining terms all on left side now. Now which term is completed? This one is completed and this one is completed. Move on the left side now. This value. That is m1 u1 as per this. m2 coming on left side minus m2 u1 and 2 m2 also coming on left side. That is 2 m2 u2. There is a possibility to take common now. u1 of m1 minus m2 plus, what about second one? 2 m2 u2. That should be equals to v1, you take common m1 plus m2. Divide the value by m1 plus m2 now. That means u1 of m1 minus m2 by, what will come? m1 plus m2 plus second term now 2 m2 by this value m1 plus m2 into u2, that should be equals to v1. It is the first value you are getting by using the two important laws. One is called law of conservation of momentum, other one is law of conservation of kinetic energy. From this, the standard shape of representation is v1 equals to m1 minus m2 by m1 plus m2 into u1 plus 2 m2 by m1 plus m2 into u2. This is the value we show it at the end after simplification. That means v2 condition is verified. Then go for the v1 now. Same procedure you should apply, and a substitution also same in that equation. I'll do that step now here. You follow those points slowly because it's a very important derivation. The books not given the full length of solution for this. That reason it will help you to understand what way the final result is coming after substitution, that value or those values. Again I take the same one. Second case we are verifying now. Now m1 of u1 minus v1 equals to, I repeat the value same as it is. Now m2 of v2 minus u2. v2 minus u2. This one I repeat again. Already have the result. What is that? v1 equals to v2 plus u2 minus u1. Be careful to write b and e letters, otherwise the results are not coming. Now the m1 of u1 minus of v1 substitute on left side now. v2 plus u2 minus u1. Right side expand now. m2 v2 minus m2 u2. Now m1 of u1 first level, simplify this, minus multiply the value inside the bracket, minus v2 minus u2 plus u1 equals to m2 v2 minus m2 u2. After substitution is over, that reason I removed this. Now again find out now m1 of it is u1 and it is u1, 2u1 minus v2 minus u2 equals to m2 v2 minus m2 u2. Next step is now again expand this, 2m1 u1 minus m1 v2 minus m1 u2, and right side now m2 v2 minus m2 u2. Same lines now, you keep the value on the right side v2. Here already this and this. Move on right side now. That means what happening? m2 v2 plus m1 v2 come on right side. Remaining on left side now. That is here I am writing. Here I am writing. That is 2m1 u1. It is already moved. Bring this to the left side now. That means m2 u2, this value, and here already there minus m1 u2. This is the value. Again you take the common now. 2m1 u1 plus u2 if we take as common, m2 minus m1, that should be equals to b2 take common, m1 plus m2. m1 plus m2. Divide the value by m1 plus m2 now. Then what will come? 2m1 by m1 plus m2. Is it visible? 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into right side value is v2. Right side value is what? v2. This is the value we got after simplifying the result. v2 equals to and v1 equals to. I conclude now. v1 equals m1 minus m2 by m1 plus m2 u1 plus another one is, both are here now, m1 minus m2 by m1 plus m2 u1 plus 2m2 by m1 plus m2 u2, whereas v2 equals to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into v2. That is the way to find the results for final velocities in case of one-dimensional elastic collision. Okay, this method will help you clearly the each step of simplification for finding the result and show the values both in terms of final velocities. One is v1, other one v2. Very much important for LAQ from the topic work, energy and power. Okay. Next one is freely falling body. Because LAQs from the topic work, power and energy, 3 are there. 2 will come in exam as per the board weightage. Definitely those are very, very important. Now that one we have to discuss now. Next one is a freely falling body. It is very simple. Freely falling body. Freely falling body. For this purpose I consider now This is the mass of the object located at point A. Now that will reach another point B whose mass is m here and will touch the ground at the point C. Still the mass is m. The total height with respect to the point A to C, that is h. The distance from A to B is x, and the remaining point is from B to ground is h minus x. Our objective to calculate the total energy that should becomes constant with respect to point A, with respect to point B, and with respect to point C. First one is calculate at point A. At point A. See now, if anything have to drop at certain height, its initial velocity becomes 0. Its initial velocity becomes 0. Okay now, at what height the object is present, height is h. Because the point A is located at a height is h from the ground. Now the potential energy you want to define, the formula is very clear, mgh. Because it is the g is an acceleration due to gravity, h is the height, m is the mass, already it is at point A. Now second value you want to calculate, that is the kinetic energy at this point. What is the kinetic energy formula? Of mv square. At point A we are calculated of m. What is the at point A? That is v square A. That means that value of the initial velocity already 0. Of m into 0 whole square. The kinetic energy is 0. Then the total energy at point A, sum of potential energy and kinetic energy. The result is how much? mgh plus 0. The resultant value is mgh. That is at point A. That is the value got at point A, mgh. Close. That is the first case we are observed. Okay now? And go for the second case now at point B. At point B. We observe at the point B, the body is at a distance, how much it should be traveled at a distance x, velocity becomes this. The height above the ground. The height above the ground point B is how much? H minus x. Okay, now h minus x is the height above the ground. Above the ground. Then you write the potential energy. Already know the formula mgh, but apply this to the present condition. With respect to ground, the height is mg into h minus x. Expand this, mgh minus